In fire protection, there's one single pipe that holds the power to make or break the entire system, and that's a fire pump suction line. If you get it right, you got a system that's going to save lives. But if you get it wrong, it's a guaranteed failure. So in this guide, we're going to break down all the essential rules from NFPA 20 and other standards to give you a practical, hands-on field guide for a perfect installation every single time. So here's what we're going to cover. We'll start with why this pipe is so incredibly important and exactly what happens when it fails. Then we'll get really practical. We'll look at how to read the plans, master 3 rules you just can't ignore, and make sure we get the sizing right. We'll wrap it all up with a step-by-step checklist you can use right on site, and then cover the paperwork you need to pass inspection and get that final sign-off. All right, let's start with the most important idea here. I want you to think of the fire pump as the heart of your entire fire protection system, okay? So if the pump is the heart, then the suction line, that's the main artery feeding it. And if that artery is blocked or damaged in any way, the heart is completely useless. It's really that simple and that critical. So what really happens when this pipe is put in the wrong way? I'm not talking about a little drip or some minor problem. No way. An improper installation means the system will have a catastrophic failure right when you need it the most. Let's take a look at the difference between a pass and a fail. This slide just lays it all out, doesn't it? A correct installation. That's on the left. It gives you a smooth, continuous flow of water with no air in it. The pump is happy, it's working perfectly, but then you look over at the right side. Yikes, that's what a bad installation causes. It creates all this turbulence and traps air pockets, which leads to something called cavitation. Honestly, it's like throwing rocks inside your pump impeller. And the result? We're talking severe vibration, a total loss of pressure, and a system that is completely and utterly useless in a fire. So, to avoid those catastrophic failures, it all starts with the plan. Before you even think about turning a wrench, you have to know exactly what you're looking at on those engineering drawings. This is, without a doubt, the first step to getting it right. Okay, when you look at an approved drawing, these are the symbols you've got to find instantly. You've got the fire pump itself, the suction line with that important flow arrow, the all-important eccentric reducer, the isolation valve, suction screen, pressure gauge, and, if you're pulling water from a tank, the anti-vortex plate. Get real familiar with these because they are the non-negotiable parts of a system that's going to pass inspection. All right, now we're at the core of the training. We're going to go over 3 critical installation rules from NFPA 20, and I want you to think of these not as suggestions but as laws. They are absolutely mandatory for any safe and compliant system. No exceptions. Rule number 1 is the big one, and it's all about one thing: giving the water a smooth, straight, calm path right into the pump. See, the pump hates turbulence. Any kind of swirling or disruption right at the inlet is going to damage it and just kill its performance. So this first rule is all about preventing that from ever happening. And the rule has a really simple name, 10D. That's just 10 times the pipe diameter. This easy little calculation is your golden ticket to stopping turbulence and protecting that pump. And what it means is you can have absolutely no elbows or T's connected directly to the pump's suction inlet, period. And look how simple this is to check right on the job site. Let's say your section pipe diameter is 250 millimeters. Okay, you just multiply that by 10. What do you get? 2,500 millimeters, or 2.5 meters. That's it. That's your answer. You need a straight, uninterrupted piece of pipe that's at least 2.5 meters long going right into that pump. It's a quick, easy check you can do in seconds. Rule number 2 is even simpler. Keep air out of the pump. Air is the absolute enemy of a fire pump. To stop it, you must use what's called an eccentric reducer. And now this is the really key part. It has to be installed with the flat side on top. If you use a concentric reducer, like the one you see on the right, you're literally creating a perfect little trap for an air pocket. That air will starve the pump of water and cause it to fail. I'm telling you, this is one of the most common and most critical mistakes people make out in the field. Okay, our third and final rule tells us what you can and cannot connect to that suction line. And it's really clear-cut. Things like control valves or throttling valves, absolutely prohibited. They just restrict the flow. What about strainers? Well, those are allowed, but you have to make sure they're sized for 150% of the flow. And then there are things like check valves. Those are conditional. They can only be installed if the authority, the civil defense or your project client, specifically asks for it and approves it in writing. So we've got the rules for how to build the line.
Now let's talk about performance. We got to ask the question, is the pipe you're installing actually big enough to deliver the massive amount of water a fire pump needs?
NFPA 20 is crystal clear about this. A fire pump can never be starved for water. What this means is, during the final test, when that pump is running at its absolute maximum, that's 150% of its rated flow, the pressure gauge at the suction inlet cannot, under any circumstances, drop below 0 psi. If you see a negative reading on that gauge, you created a vacuum. That means your pipe is too small, and it is an instant critical failure of the test. Luckily, you don't have to be a math genius to figure this out. NFPA 20 actually gives us a table that makes it super simple. So look at this example. For a 1000 GPM pump, the code says you need a minimum suction pipe size of 8 inches. If you try to save a little money and install a 6-inch pipe, it's an automatic code violation and a guaranteed failed inspection. It's just not worth it. Okay, so we've covered all the rules in the theory. Now let's put it all together into a practical step-by-step checklist that you can use right on the project site. Think of this as your roadmap to a perfect installation. Following these 7 steps in this exact order is the key to success. First, verify your approved drawings and make sure you have the right materials on site. Second, install that mandatory 10D straight pipe section. Third, fit that eccentric reducer, flat side up. Fourth, fix your supports so they're carrying the weight without putting any stress on the pipe. Fifth, install your screen and anti-vortex plate. Sixth, mount the suction pressure gauge. And finally, number 7, tighten all your flange bolts evenly and to the right torque. You follow this checklist, you'll be ready for any inspection.
But hold on, the job isn't done just because the last bolt is tight. Now you have to prove that your work is correct. And that means having all the right paperwork ready for the QA/QC inspector and for that final project handover.
Trust me, an inspector from the consultant, the client, or a company like Saudi Aramco is going to ask for this folder. Having your method statement, your inspection requests, your test reports, and all your commissioning reports organized and ready to go, that's the final step. It shows you're professional and it proves your work meets every single standard. And this right here, this is the single most important thing to take away from all of this. Every single measurement you take, every flange you bolt, every document you sign, it all matters. Why? Because what you're building isn't just a piece of plumbing. It's a critical life safety system. Its job is to save property and, most importantly, to save lives. By carefully following the rules, the drawings, and the checklist that we've gone through, you can confidently answer yes